Thanks very much for joining, Adam. So Adam is here today to speak to us about his work on NLP in the particular application of South Africa's COVID-19 What's Up hotline. Sounds really interesting. Adam, I have no bio for you, so I can't make a informed introduction. So I'll allow you then to go ahead and introduce yourself, please.
Thanks everyone for joining, and thank you for moderating this. I don't think you have a name tag here, but thank you anyway. So I'm Adam Chang. I'm a data scientist at ID Insight based in Dakar, Senegal, and I'll explain more about that in a bit. But this talk just centers on work we've done with a COVID hotline in South Africa and answering people's questions. So brief overview of the talk. I'll just start introducing the organizations and platforms involved. Some of them are pretty nifty, like innovative things in the developing world. Then we'll talk about like possible machine learning solutions in this context and related to this problem. I'll give a more detailed overview of what model we're using and how we built out a solution. Then after that, we'll talk about like two kind of sidebar things related to our model. One is like, how do you contextualize something that's largely been developed in the global north by Americans to work in a different context? And also, how do you maximize efficiency and like minimize computation time when resources are scarce? And that's about it. So ID Insight, which is the organization I work for, we're around 200 people worldwide. Been around for like 10 years now. One of my managers always likes to joke, but not really joke, that we're always goading the plane as we're flying. But essentially we have a traditional business of like working on evaluations and monitoring with governments and NGOs, but now we have a growing data science and engineering arm. We're around like 10 to 15 people now, but hiring rapidly. So there's a link there. And we're partnered with an organization called breakout.org. So they do mobile health technology, largely based in South Africa and operating worldwide. And I have a blurb from them that I've been asked to read. So breakout.org is a South African nonprofit organization that has been using mobile technology to improve health and health systems since 2007. Using simple communications such as SMS, USSD, and IP messaging, specifically WhatsApp, breakout.org's approach harnesses the power of communication between citizens, health workers, and the health system to ensure that 1, citizens are informed and empowered, 2, health workers are supported and valued, and 3, health system officials have the information they need to make informed and effective decisions to improve service delivery and quality. Cool. So back in 2014, South Africa's National Department of Health and Breakout introduced a mobile service called Mom Connect. So this essentially was like a two-way connection between expectant mothers and health officials to like essentially maximize like people's success and information they had during pregnancy. The blurb I have from Breakout for that is, Mom Connect is the National Department of Health in South Africa's national mobile maternal messaging program, where mothers attending their 4th antenatal visit in any public health facility in the country can sign up to receive stage-based messaging to help them care for themselves and their baby through pregnancy and up until the baby is 2 years old. Additionally, mothers have access to a text-based help desk where they can ask questions and get responses directly from the NDOH. Launched in 2014, the program was the first national-scale program of its kind and has enrolled over 4 million mothers, which represents between 70 and 80% of the mothers giving birth in the public health system over this period. So nowadays, when you hear about like innovations like this, they seem pretty like run of the mill, but this was, all the way back in 2014. And it was a pretty nifty way to connect citizens with the government. So that was launched by South Africa's National Department of Health and Breakout. And then this year in March 2020, as what hit, these partnered organizations also launched something called Health Connect for COVID. So the blurb, this is the last blurb. The blurb I have from that is, In March 2020, Breakout.org realized that the Health Connect approach could be rapidly deployed to address many aspects of the challenges faced by organizations and governments worldwide related to COVID-19. Health Connect for COVID-19 was initially launched in South Africa as an informational WhatsApp service for the National Department of Health and quickly attracted the interest of other countries and organizations, resulting in similar instances of the service being launched for the World Health Organization, 10 other governments, and 2 additional public health organizations within a few months. These services have now reached over 26 million citizens and health workers with over 650 million critical COVID-19 messages in 26 languages. Okay, awesome. So essentially, Mom Connect and Health Connect for COVID are these two health information-based services that operate over WhatsApp and are like pretty freely accessible to all citizens. These are useful and important programs. Like tens of millions of people in a bunch of countries and 26 languages use these programs, but they're very menu-driven and menu-dependent. So if you were to have tried the COVID Connect service, the Health Connect for COVID, before ID Insight and Breakout worked on this, it was very much like a phone tree where like you could select from a list of options, whether it's like prevention, symptoms, or treatment. You type like prevention for prevention, or you type like 8 for like symptoms or something. And then you get like another menu and you can access information that way. But it's pretty traditional, like a phone tree almost. And it's not like super responsive or intuitive for citizens to use. We, in partnership with Breakout, thought that machine learning could come into this picture. We want users to interact naturally with these services and ask their own questions. And that just lets people get information completely relevant to what they want to know without having to navigate a phone tree. And it's also important because it gives health authorities a lot better insight into what people are actually wondering about, right? Like trends and topics with COVID and like vaccines change overnight almost. And health authorities this way can like get insight on what people are asking about, so they can, edit the FAQs that are in the service, but they can even change like offline messaging. Like if everyone's suddenly scared about microchips, like maybe they need to launch some like TV campaigns. The problem with this is that user question volume is much greater than human answering capability by some of the usage numbers I shared previously. So here's where machine learning comes into the picture. Chatbots aren't a new thing, but this can't really be any old chatbot. Like, I don't know, like every bank's like mobile application has a chatbot. Even like most of the banks here in Senegal have a chatbot on their mobile application. But you need to be very careful with chatbots, right? Because misinformation and distrust are very rampant in our context. Like this is a combination of COVID, vaccines, like really global and terrible, like vaccine inequality, like things that are sent over WhatsApp. And because this is a partnership with the government and the National Department of Health, it's really critical that accuracy is fully there. This is Hugging Face's Transformers, which is a well-known like library that works with a lot of the fancy NLP technology like BERT and ELMO and GPT. And like, if you try to ask it a question like, did Bill Gates put microchips in vaccines? The answers can really like get you all over the place, right? Like nobody mentioned Monsanto. What does Monsanto have to do with this? But it's basically a demonstration that you can't just like throw this at some off-the-shelf model. So here we don't particularly want anything fancy. We have pretty limited resources to handle millions of users. It's really critical that we avoid wrong information. And all of this needs to be like explainable to like government and civil society stakeholders who like don't know what BERT is. Basically, we need something quite supervised, which like NLP models generally aren't. Any questions so far from anyone about the context or the setup of this problem? You can type it in the chat or the Q&A. And feel free to ask questions throughout.
Yeah, please feel free to raise hands also.
Okay, Awesome. I'll keep going, but please ask questions. I know that I often am not clear and go too fast. Cool. So starting from fundamentals here of like how you build this kind of system, it's pretty clear that like your solution needs to center on a bank of FAQs. Like that's the only way that you ensure information that goes out is accurate, right? Like you need a pool of accurate information, and that's the only thing you send out. So, right, like even if it's not fully accurate, relevant to what a user is asking for, at least you're not sending out like fake news. So this is like a very supervised aspect of our model. And this makes your like model design and model choice a lot simpler, because now it's just like you need to match user questions to the bank of FAQs that you have. Like maybe you have 3 FAQs about pregnancy, a couple FAQs about like microchips and stuff. And you get a question comes in, like how do you match it? You can try doing things in a traditional like train a model kind of manner, right? You like fit n-grams to a bunch of training data and user questions. You can build like sparse TF-IDF matrices, you select features, you fit some classifiers. So like, something like this table, you can just directly ingest into pandas and like call like, 2 functions and like NOTK and like whatever. But there's some significant problems with that approach. One is that you have no training data here. Like, even if you could source it, like COVID changes really quickly, like basically overnight, and these topics like come out of nowhere. So you have no training data. And even if you have training data, like that training data is all but useless like a month from now. The other thing is that your FAQ bank needs to evolve over time. So you're going to have FAQs added, right? Like as soon as some rumor comes out about George Soros, like you need some FAQs about him. You're going to have FAQs that are removed when like people are no longer asking about something, like beta variant. When did anyone last ask about the beta variant? Some FAQs are going to be like split, some are modified, and like essentially you can't really train like some classifier, like one against many or whatever that predicts like FAQ C1 given Q and FAQ CN given Q, because you need to put in like n+1, you need to put in n+2, and you're going to alter like all the relevant parts of your FAQ. So even if you like use BERT in like this manner where you try to fit a traditional supervised predictive model, like it just won't work. So any questions there, or anyone want to suggest, maybe like guess at the approach that we did show us here, NLP knowledge?
I have one question myself. Oh, sorry. We have some questions here in the chat. I wasn't monitoring very closely. So Ben has asked, maybe it's a dumb question, is the analysis done only on each text or the string of responses and what people said earlier?
That's a great question. And you would probably want to do the second one, right? Because that gives you as much information as possible. But that's not what we do necessarily. That's what we're adapting towards, and I'll explain that in a bit. Similarity between user question and bank, seeded topic models. So no seeded topic models here, just because like if you need to adjust a hierarchical model of that nature, like you need a data scientist essentially like always working on this problem when like new FAQs are going to be added to topics change, which like doesn't really make for a super sustainable long run solution. And then here's a similarity between user question and the FAQ bank. Yeah, exactly. So we basically only want to rely on the user question and then the themes of each FAQ. And this is what word embeddings are incredibly useful for. So I'm sure most of you know what this is, but word embeddings have become this like, like the center of NLP over the past 10 years or so. Basically where you can project each word into a vocabulary into some like in-dimensional space. So here everything is on a 2D grid, but usually it's like, like 100 or 300 or more dimensions. And words that are related to each other will be closer together, and you'll see some pretty cool relations, right? Where like Paris is to France as London is to England, like if you do the vector subtraction or something. But basically, this really helps with our problem because, like, if you have an FAQ that's about France, but like suddenly, like the rumors change overnight, and now it's like England putting microchips into the vaccine or something. Like this model will still detect that these topics are similar. Or like if people are asking, like, are there microchips in vaccines in Paris? Like this model still gets that. So word embeddings are pretty useful here. You can start with the basics, and that's what we do. Essentially, for each FAQ in our bank, we just assign it relevant tags that need to match a user query. And this is done with like trained content moderators. We've built out some tools for this also, but like if you get an FAQ like, is it safe to get the vaccine when pregnant? Then maybe you tag it with pregnant, vaccine, and safe, so that if a user question comes in and it relates to all three of those tags more or less, then like it seems like you should send out that FAQ. So this is an overview of what that looks like. You see this incoming message comes in that's like asking, the person's expecting and they're expecting a child and they're wondering if it's safe to get vaccinated. The first FAQ might be about like Bill Gates put a microchip in the vaccine or something, but like it would be tagged with those and that doesn't match anything. The second FAQ might be just about like vaccine and pregnant. And since this question has a lot to do with vaccine and pregnant, even though it doesn't have like exact word matches by any means, it would score highly and it would be sent out. Maybe you have a final FAQ that's about like vaccine and side effects or something, but the tags wouldn't match. So essentially like this, you can calculate a score for each FAQ in your bank and then send out like what's most relevant.
Adam, I'll just point out that we have 3 minutes left in your time.
Sorry, is it 3 minutes or 13 minutes?
I'm so sorry. Yes, indeed it is 13 minutes. Disregard, please.
No worries. Cool. So just some sidebars on the model, which I've thought are pretty interesting. One is contextualization. So when you build these kinds of embeddings, they're always pre-trained and trained on like very large corpuses of text. So in our case, we're using the standard like Google News word to vec model, like skipgrams, like negative sampling, all that. What that means though is that like the context that our model is being deployed in and works in is pretty different than where it was trained, right? So like these are informal messages sent by South African citizens to like a WhatsApp hotline, right? Like nobody's gonna type out like very formal questions because it's WhatsApp. But our training data comes from like news headlines from the US and Europe. And like you can just imagine how everything differs between these contexts. So there are four main things maybe you need to be careful about. One is like misspellings and typos and like even regional English differences, like people are typing on phone keyboards. You also need to be careful about like poor grammar and syntax because that differs, text shorthand, and finally like regional phrases and slang, right? Like apparently if you say jab in like a lot of the English speaking world, that means vaccine, but like as an American, I have no idea what that means. So first thing, misspellings and typos. What happens when people misspell messages that are sent to this hotline? It's a very easy problem to detect what words are misspelled. Like there are very traditional libraries for this, including Kunspell, and you can even find like what alternative spellings the user might have meant, right? That's just like edit distance. But it's a much harder problem to determine like which is the correct word that you use, right? So like here, if the user spells like PAINE, like a human would look at this and be like, oh, they're asking about vaccines, like it should be pain. But like, how do you train a model to like, look at all of these and say, oh, is it T-pain? No, it's PAIN. But this is again somewhere where you can use the context and embeddings. So like we have a pretty known context of like COVID vaccines and like specifically all the FAQs related to that. And like, we'll have vectors for all of those words. And, you know, out of all of these suggestions raised by the Huntsville library, you can like find ones that are most similar to the actual context and like embeddings in the FAQs. And essentially we did some experiments with this where like we artificially added errors to possible user queries. So like if you look here, like this is an error rate of like 0.07 on each character. And like these messages are pretty jumbled, right? Like most people would be more careful than this, even over WhatsApp. The graph on the right, essentially you want to compare between the solid line of a color and the dotted line of the color. So dotted line shows degraded performance as there's more typos, like as error rate on each character goes up on the x-axis. But solid line is using the like misspelling correction that we're doing, just like contextualized spell check. And like you can see that performance like barely goes down even when there are a lot of typos, which is pretty amazing. Other things you want to worry about, poor grammar and syntax. How do you fix this? You actually don't care about poor grammar and syntax because when you deal with embeddings, you're only looking at like words and like n-grams at best, especially static embeddings. This is different if you're doing something with like BERT where embeddings are contextualized, but here like the grammar and the syntax doesn't matter as long as the words are there, which is like a, you know, it's a simplifying thing, but it's a feature for us. Other things you want to worry about, text shorthand and regional phrases and slang. So what's a jab, what's a laity? Here you can pretty much just use a glossary because like some of these things are so specific in the context that like, you know, that if somebody sends jab to like a WhatsApp hotline about COVID, they probably mean vaccine. You know, if somebody sends the word shot to a WhatsApp hotline about COVID, like you'd hope they mean vaccine, right? Like, so even shot, you can say like, oh, they probably meant vaccine. Even something like COVID, because our training data largely came from, you know, this like Google News stuff in like 2013 and 2014. COVID's nowhere in that data set, but you can like put it as a linear combination of other embeddings. So here like virus and pandemic, and like turns out that works good enough, right? Because you're just looking at like where things sit in the n-dimensional space, like the 300-dimensional space. Any questions so far?
Yes, there's one from Liev. He's asking, Ari, the user questions to FAQ matching. Are you matching sentence embeddings to FAQ tag embeddings, or are you doing some NER or tag extraction from the user's questions first and then matching to the FAQ terms?
Great question. And this is something I was not specific about. We are not matching sentence embeddings. I don't know if you've tried to use sentence embeddings, but like at least in Jensen's like doc2vec library, it's the sentence embedding quality is much lower than the word embedding quality, let's say. So no, we don't capture embeddings for each sentence. What we do is somewhat clever, where like for each sentence, we extract the words that are likely going to be most relevant to each FAQ. So like, let me try to go back a few slides and share this. Here, we, when we want to compare the similarity to like the vaccine tag, for example, we're going to take the like top 10% of this message that's most similar to vaccine or something. So it's like you can think about it as like you have two groups of like endpoints in like 50 or 100 or 300 dimensional space, right? Like how do you like match like these points to each other, right? They're like giant like clusters essentially, right? You can't do like, it's very hard to try to like project these two groups of points into something else and then like check the distance, but like you can just compare the closest points within the cluster, right? And I think if you were to do this like intuitively on paper, you would do that. Cool. I'm just gonna try to finish this presentation really quickly and then take some more questions. So lastly, some speed improvements. We did this at first and it could handle like 8 requests per second, which, you know, didn't really fuss me, but since millions of people use this service, that was unacceptable to our partners. So we did some profiling. And if you run this like function, if you run our like matching algorithm like 400 times, it takes like 40 seconds. But then you notice that like two functions pretty much dominate all of this. So one is check array in scikit-learn, takes 22 seconds, so over half. And then another function called assert all finite takes like 10 seconds. So these combined take up like 80–90% of the time that's being used for your function calls. And like, it really doesn't sound like you need to like check arrays, right? Like what does check array do? It just does input validation. And assert all finite does the same thing. But we know that like we're feeding in valid vectors because we train these, we're guaranteed that they're like perfect size vectors and they're all finite anyway. So what do you do when you have something like this and you want to speed it up? Well, you take out scikit-learn. The only reason we used scikit-learn was to do some like linear algebra cosine similarity here. But since everything here is like just a dot product, you can just use np dot, right? And then like, I guess the math should take the same amount of time, but it should take much less time to do input validation because we're pretty sure the inputs are safe. Turns out you can go one step further. In cosine similarity, you have like this denominator term that's there to normalize all of the vectors, right? Because if you have like two things that are like really far out, they're gonna have a much larger dot product, regardless of like, like if there are two things that are short and have the same angle, like that will have a much lesser dot product, and you want those to be equal because you only care about the angle. But you'll notice that you have to do 3 dot products to do the normalization. Better yet, you can just pre-normalize all of the word vectors embeddings beforehand, and now you only need to do a single call to np dot. So if you do all of this, then it gets to 100 requests per second, which is good enough for now on a single EC2 server. Yeah, that's it. Some results and next steps. Based on early benchmarking of user queries that could be answered by the FAQ bank, over 70% are successfully matched. The downside there is that a lot of user queries are about topics not covered by the FAQs. So what that means is we're burning out more real-time monitoring of the message stream, and our partners at PrayCal are working on adapting the FAQ bank in more real time. Other things we're looking at are training and sourcing language embeddings in other languages, since PrayCal works in over 26 languages. Finally, model calibration. I saw there was a question about feedback that Ben answered, but right now we do collect feedback from users on how well this answered their question. But more than that, I think we want a layer where like you just have latent estimates that change over time of like how popular each FAQ is and how accurate it is when we send it out. Cool. That's all from me. Big thank you to everyone, especially to the hosts of PyData and people who are listening, as well as our collaborators at PrayCal and ID Insight. And this work, I am required to say, is funded by the Global Innovation Fund very generously.
Great. Thank you very much, Adam. There's a couple more questions in the Q&A, but I think we're a bit out of time there. So maybe if you guys could pass those along via Slack, that would be excellent.
Okay, awesome.
Okay.
Thank you.
Thank you, Adam.